A manual transmission, also known as gearbox, is a type of transmission that is used in motor vehicle applications and uses gears to provide speed and torque conversion from engine to the wheels of a motor vehicle. In this video, concept of gear ratio, sliding mesh gearbox, constant mesh gearbox, double declutching, and then synchro mesh gearbox, which is used in most of the modern vehicle with manual transmission, will be explained. Consider two gears which are in mesh with each other. The number of teeth on larger gear is twice as that on smaller gear. Therefore, smaller gear will have to make 2 revolutions for every 1 revolution of larger gear, so that it can traverse all the teeth on larger gear. That means smaller gear is rotating at double the speed of larger gear. The gear ratio is defined as input speed relative to output speed and is equal to number of teeth on output gear divided by the number of teeth on input gear. The power input is given by input torque times the input gear rotational speed, and it must be equal to the output power, that is output torque times the rotational speed of output gear. Since the rotational speed of output gear is half of the input gear, therefore torque delivered by output shaft will be double of the input torque. This means that we can get large torque at low speed by applying low torque but at higher speed. This basic principle is used in gearbox to achieve different torque and speed requirements. An automobile requires large torque when starting from rest, climbing hill, or pulling load. In these situations, speed of vehicle is not so important. On the other hand, when running at high speed on level road, high torque is not required because of momentum of vehicle. And it would be more preferable to just keep the wheels rotating at higher speed. Engine is not capable of working efficiently for such wide speed range. Therefore, to permit this relative motion between the engine and the wheel, a set of gear called transmission system or gearbox is used. A sliding mesh gearbox is the simplest and oldest type of gearbox. It consists of the input shaft, the output shaft, and counter shaft. The input shaft drives power from the engine and transfers it to output shaft through gears mounted on counter shaft. The output shaft then transmits it to propeller shaft for onward transmission to road wheel. The input shaft contains gear called as clutch gear, which is in constant mesh with counter shaft. The output shaft is splined and gears on output shaft can slide axially to mesh with the corresponding gears on counter shaft and therefore can have different gear ratios. Shifting gears in this type of gearbox is noisy and requires considerable skill to shift gear without damaging it. To overcome this difficulty, constant mesh type gearbox is developed. Similar to sliding mesh gearbox, the constant mesh gearbox consists of input shaft which drives power from the engine through a clutch. The gears on output shaft are not fixed and are free to rotate on the output shaft. These gears are shown by dark color. Different size gears are fixed on counter shaft and cannot have any type of motion relative to counter shaft. The fixed gears are shown by blue color. The gears mesh with the corresponding gears on output shaft and always remain in mesh. These meshing gears have different gear ratios. For example, for the first gear, the larger gear has 3 times the teeth on the smaller gear. Therefore, larger gear turns 3 times slower than the smaller gear and can transmit 3 times the torque available at counter shaft. Similarly, for the second gear, the number of teeth on larger gear is 2 times the number of teeth on smaller gear. Therefore, the larger gear turns 2 times slower than the counter shaft. In fact, all the gears on output shaft rotate at different speed according to their gear ratio. On the other hand, the output shaft is connected to wheel and hence rotate at speed related to wheels. For transmitting power to output shaft, one of the freely rotating gears needs to be locked to the output shaft. To do so, a hub is fixed to the output shaft. Thus, hub rotate with the output shaft. A sleeve is splined to the hub and can slide axially on the hub. This sleeve can be slid and can be engaged with the synchro teeth on the side of the gear. This locks the gear to the output shaft through the hub. Thus, the locked gear, the output shaft, shift sleeve and the hub act as one unit and rotate at same speed. Similarly, the sleeve can be slid to engage with synchro teeth on the side of the second gear, and hence second gear get locked to the output shaft through the hub. Now second gear and output shaft rotate at same speed. And power is transmitted from engine to input shaft to counter shaft and then to the second gear. For locking third and fourth gear on output shaft, another hub and shift sleeve is provided. Engaging sleeve to third gear locks the third gear to output shaft. For fourth gear, the shift sleeve is directly engaged with the input shaft gear and power is transmitted directly to the output shaft without any speed reduction and referred as direct drive. But there is problem. In constant mesh gearbox, for smooth engagement of shift sleeve with the gear, it is necessary that speed of gear and the shift sleeve must be equal. Suppose we want to shift gear from fourth to first. At this position, the fourth gear is locked to the output shaft and hence the output shaft is rotating at the speed of fourth gear. Therefore, shift sleeve is rotating much faster than the first gear and as such the shift sleeve cannot be engaged with the first gear smoothly. To engage shift sleeve with the first gear, the speed of the first gear has to be increased to match the speed of the shift sleeve. To do so, the clutch is disengaged first time by depressing the clutch pedal and the gear system is brought in neutral position. Then the clutch is engaged by releasing the clutch pedal and engine is accelerated to increase the speed of the gear system. When driver thinks that speed of the first gear matches the speed of the shift sleeve, the clutch is disengaged again second time and the first gear is engaged. Then clutch is re-engaged by releasing the clutch pedal. Thus, now power is transmitted through the first gear. Thus, in order to change the gear, the driver has to disengage the clutch twice. Therefore, it is referred as double declutching. To avoid this problem, most modern manual transmission vehicles are fitted with a synchronized gearbox. In synchronized gearbox, the speed of the shift sleeve and the gear desired to be locked on the output shaft is matched automatically. This is done by employing synchronizer ring. Synchronizer ring is fitted in such a way that it rotates with the output shaft and can also have axial movement. Synchronizer ring has internal cone. The gears are provided with mating cone which matches the synchronizer ring internal cone and forms cone clutch. Suppose vehicle is standing still and therefore output shaft is not rotating. Now we want to lock first gear to output shaft. For this, the clutch pedal is depressed so that engine is disconnected from transmission and thus transmission system is rotating at its own due to its inertia. Now when shift sleeve is pushed before the teeth can engage, the cone clutch engages first. This causes friction between synchronizer ring and the mating cone on the gear. This frictional force overcomes the inertia of the transmission and the speed of the gear matches the speed of the shift sleeve. Further pushing the shift sleeve causes it to smoothly engage with the gear. Then clutch is re-engaged by releasing the clutch pedal and now power is transmitted through the first gear, which causes output shaft to rotate and vehicle starts moving. Similarly, for the second gear, the friction between the synchronizer ring and second gear causes the speed of second gear becomes equal to the shift sleeve, and the shift sleeve is engaged smoothly with the second gear. For reverse gear, teeth are provided on shift sleeve and a corresponding gear on the counter shaft. These gears are not meshed directly. To connect them, an idler gear is used so that direction of rotation can be reversed. When reverse gear is required, the gear on counter shaft and that on shift sleeve is connected by shifting the idler gear. And thus, output shaft rotate in reverse direction. Reverse gear is not synchronized, thus vehicle has to be stopped before applying the reverse gear. For higher speed, a fifth gear is provided. In this case, the freely rotating gear is on the counter shaft and fixed gear is provided on the output shaft. The gear can be locked on counter shaft with the help of shift sleeve and a hub fixed on counter shaft. Shift shaft are provided to change the gears. At this position, vehicle is in reverse. In neutral position. Now first gear is applied. Again in neutral. Now second gear is applied. Again in neutral. Now third gear is applied. Similarly, fourth and fifth gear are selected.